Hi, I'm Kevin Koenig, and I'd like to introduce you to a new and innovative product called the Hydronicude. The Hydronicude is a 55-watt wet rotor circulator with a variable speed ECM motor. The unique body of the Hydronicude allows you to build a reliable, compact, and efficient pumping system very quickly. Let's take a look at a typical installation. Once the modules are connected to one another and the two additional fittings we've added, we're able to screw the pumping module onto the wall using the integral feet that are cast into the Hydronicude body. No additional hanging apparatus is required. The common pipe is the source of water for all four pumps. The lower pump is our dedicated boiler pump and keeps an adequate flow in the heat exchanger of the boiler when it's running, regardless of what the zone pumps are doing. The three zone pumps also draw off the common pipe and discharge their water out to the respective zones. Water returning from the zones is able to enter the common pipe through the fitting we've added on the bottom of the common pipe. This completes the two circuits: our primary boiler circuit and our secondary zone circuit. Any air that returns from the circuits, the zones, enters the common pipe and migrates to the top of the common pipe and is vented through the 1.5-inch vent we have on the top. Testing has shown us that installing the common pipe vertically and affixing the pump horizontally and allowing the impellers to draw water off the side of the common pipe gives us a system that's very resistant to air binding. In addition to the ability of the common pipe to separate air efficiently, the circulators have dry run protection built into their software. In the event the circulator recognizes a dry run condition or an airbound condition, the circulator begins what we call a dry run cycle, where it ramps down slowly, speeds back up again slowly to try and resolve the airbound condition. If after a period of time this doesn't resolve the airbound condition, the pump will shut down so it doesn't burn itself up. Inside each Hydronicude body is a suction isolation ball valve. We can remove any motor we would like to off the common pipe without disrupting the flow to the other circuits by simply closing the suction isolation ball valve, which is actuated by a stem coming out the back side of the body. There's a check valve in the discharge of the pump that prevents water from flowing from the zone back into the body. So very quickly we can remove the screw-ring off the pump and take the motor off the common pipe. The spacious internal volume of the Hydronicude body, in conjunction with the discharge check valve installed in the discharge of the pump, allows us to create primary and secondary circuits and achieve efficient hydraulic decoupling so that we don't have unwanted flow in circuits that are turned off. In this particular installation, at startup, what we would do is close the common return valve here, open the common drain valve here, hook our hose on the return line, close all our suction isolation ball valves for these three zone pumps, allow the city water or the fill to come in and pressurize the common pipe. At this point, the highest point in the system is the 1.5-inch vent, so this part of the system becomes fully flooded, with the exception of this high pipe here. Once we turn the boiler circulator on, it'll drive the air out through velocity to the heat exchanger, and we become completely flooded in the heat exchanger. Once this portion of the system is flooded, we can go zone by zone, opening up the suction isolation ball valve, letting the fluid flow through the circuit and purge out the common return line. So when the first zone is purged, we move on to the second and then to the third. So we're able to power purge this system very quickly with only one drain connection on the system. Once the system is flooded, it's very resistant to any future air binding. Let's take a closer look at the Hydronicude body. The patented Hydronicude body is unique in the sense that it has two inlets and one outlet. The motor and pump assembly is held onto the cast iron body with a screw ring. To remove the pump, you simply rotate the screw ring counterclockwise and detach the pump. The inlet of the body is threaded. The body is coated at the factory and the threads are sealed with an automotive type sealant to keep them clean and free of corrosion, to eliminate connection leaks in the field. The Hydronicude has a unique hollow floating ball that we use to isolate the suction side of the pump. In the open position, the 3 ports of the ball are exposed to the impeller, and water is free to flow from the common pipe to the impeller. In the closed position, the solid portion of the ball seals against the impeller side of the cavity, thus isolating the suction of the pump from the common body. The pressure drop through the common body is the same whether the valve is in the open or closed position. The spacious internal volume of the volute gives us a very low pressure drop, which enables us to create this primary and secondary circuitry efficiently. There's a removable discharge check valve that we can install into the discharge nozzle of the pump if you want it. It's not always needed, but in certain cases it is. So we have the option of installing it or not using it. The body of the volute has integral mounting feet. Modules that are connected to one another can be quickly mounted to a flat surface simply using the mounting feet that are cast into the body. This provides a very sturdy and stable mounting feature for the bodies. The spherical rotor pump used for the Hydronicude is adjustable from about 9 to 55 watts. It's available in manual speed, which is our vario version, and auto, which is proportional pressure, generally used when you're using zone valves. The only moving part in the pump is the spherical rotor. There is no shaft. Typically, wet rotor circulators use a ceramic shaft and carbon bearings. This pump has no shaft. They've essentially made the impeller out of a magnet. As you can see, air that enters the common pipe has a very free path upward. And for the air to get to the impeller, it has to pass through the ball. The likelihood of the air getting to the ball rather than the other passageways around the ball is fairly low. Air that comes through the common body easily passes the impeller and heads up the column toward the air vent. Even on a simple system, such as a single cast iron boiler with one pump, the Hydronicude makes the installation very quick and compact. Here we've taken a top outlet cast iron boiler. We simply screwed a close nipple into the outlet, affixed a cast iron cross, another close nipple, and then mounted our Hydronicude with our 1.5-inch vent. The pump discharges back, up against the wall, out it goes. The auto version would be fine if you had 4 or 5 zone valves on this, or if there was more than one pump requirement, we'd simply add another close nipple and then insert our vent onto the next pump up. Air problems and poor hydraulic pumping conditions usually associated with stick-built systems are virtually eliminated when piping with the Hydronicude piping system. The installed cost of a Hydronicude pumping system is on par with that of a conventionally piped system using conventional circulators. The Hydronicude pumping system consumes approximately 50 to 85% less power than conventionally piped hydronic system using standard circulators. So the next time you're tasked with building a hydronic pumping system, keep in mind the reliability, efficiency, and value the Hydronicude will bring to you and your customers.